Hi everyone, today's lesson is a really quick one from Unit 5. We're going to be taking a look at notes number 3, which is all about transformations and congruence. So the main objective of today's lesson is just to be able to identify a type of transformation given two figures. In our warm-up, we're going to graph at the triangle with the following vertices. A is at 1, 4, so that's right here. B is at 3, negative 2. And C is at negative 1, 1. So we're going to take and just form a triangle from those 3 points. Okay, so now we're going to transform each vertex of this triangle using the rule that says take x and y and transform them by subtracting 2 from x and 1 from y. So if you recall from our previous lesson, this means that we need to move left 2 and down 1. That's because we're subtracting 2 from the x value. That's what causes it to move to the left 2. And since we're subtracting 1 from y, it moves it down 1. So let's find our points first. Just by plugging 1, 4 in for x and y, and we'd see that we would end up at negative 1, comma 3. Because 1 minus 2 is negative 1, and 4 minus 1 is 3. B prime will be at 1, comma negative 3, and C prime will be at negative 3, comma 0. So if you take a minute and plot those 3 points, so we see A is at negative 1, 3, so that's A prime. B prime is at 1, negative 3, and C prime is at negative 3, 0. And I should have had you check by counting before we drew it in there, but we can check it now by counting. So if you check it out, we said that this rule told us to go to the left 2, so there's left 2, down 1, that checks out, left 2, down 1, that checks out, left 2, down 1, that checks out. Alright, so my hope is that you recognize this kind of transformation just from the rule alone. This transformation is called a translation. We're just shifting it. Right, the next question asks, are the pre-image and the image congruent to each other? Meaning, are they exactly the same size and shape? And the answer to that is yes. Right. And when the pre-image and image are congruent, we should know that that's called an isometry. Right. So a review question says, in which other transformations are the pre-image and image congruent? Well, in reflections, rotations, and glide reflections. The pre-image and image are congruent. So remember, the only one that we have studied that is a transformation where it's not an isometry is a dilation. Okay. All right. When we talk about keeping a figure congruent, but we're changing it, we're moving it around somehow, we describe that as a rigid motion. So a rigid motion is a transformation that preserves length, meaning the sides of your triangle or your quadrilaterals stay the same, and it also preserves angle measure. Okay, next we're going to take a look at 4 sets of figures, and we're going to see if we can identify which type of transformation they show, and also if it is a rigid motion or not. Okay, so it says if the transformation illustrates rigid motion, identify the type of rigid motion. Right, so in number 1, if we notice, we have triangle DEF on the left, and then D prime, E prime, F prime on the right. And what I notice is that if I draw this line, this vertical line right down the center, then E would map to E prime, F maps to F prime. So this is a reflection. and we can say that it is a rigid motion. And that's because the pre-image and the image are congruent. So we have congruent figures. It's definitely rigid. Okay, number 2. This is an example of rigid motion because, again, the pre-image and image are congruent. Right. So we do have congruent figures. This one might be a little bit tougher for you to see. It's not a reflection in this case because we're going from J all the way around here to J prime. This one is a half turn. And if you recall, the notation for that is H sub O, like a half turn about the origin. So let's say the origin is about right there. Now you can also say that it's a rotation of 180 degrees. Okay? So yes, it is a rigid motion. Number 3 is our only scenario that's not rigid. Okay, we have this little triangle right here, KLM, and it's mapped onto this much larger triangle, K prime, L prime, M prime. All right, so this one is not rigid. Okay. And the reason why it's not rigid motion, again, is because it's a dilation. One triangle is bigger than the other. Okay, finally, in number 4, this is something that we did not spend a whole lot of time on in our previous unit. And this is what's referred to as a glide reflection. Notice that this triangle ABC right here was shifted to the right. That's your glide. And then it was reflected over this horizontal line. So it's a glide reflection. And notice that the triangle stays the same all the way through. So we have congruent figures. So yes, this is rigid. Okay, that's it for the notes. I promised they would be quick. So good luck on your homework. And as always, make sure you speak up if you have any questions.